Here's the review for Unit 14.1 and 14.2 for graphing sine and cosine. So for number 1, we're going to look at the midline. And this is pretty simple because they give us the midline right here, are dashed letters, dashed line. It's the distance up and the distance down have to be the same to the max and the min. So that's going to be the line y equals 2. The amplitude is the distance that you're climbing to get to the maximum from your midline, or to get to the minimum from your midline. You can also use a calculation. 1, 2, 3, 4, 5. It's 5 to that point. It's -1 here. So you could say 5 minus -1 over 2. So that's 5 plus 1 over 2. That's 6 over 2, which is 3. I just think it's as easy to count 1, 2, 3. So the amplitude is 3. The period, looking at your graph, we're starting here. If you want to call this a sine graph, it looks like the sine graph is reflected. But if that's a sine graph and it would end here, then the period starts at 0 and goes to 4 pi, so it is 4 pi. The second one, our midline, the distance up and the distance down have to be the same, so it's y equals 0. The amplitude would be 2. The period, if we're looking at a sine graph, well, sine would really be here. Sine graph, it's reflected, and it would come up and over. It ends at 6 pi, but it's starting at -2. So that's still 2, 4, 6, 8. That's 8 pi total. Or you could look at the cosine. Don't know if you've ever seen the difference. Try this color. That would be a cosine graph, and it's starting at 0, and it's going all the way until 8 pi. So that's a little clearer on why it is 8 pi. Our midline, pretty clear that that's going to be y equals 1. The amplitude, the distance up or the distance down, is 1. The period, well, if we would notice that the graph seems to climb to here, but that's not a sine or a cosine graph. That's only part of one. There is your cosine. It comes from way over here, and it climbs up, and it comes back down. It's actually a reflection of a cosine, but it's a cosine. So we're going from -pi all the way to positive pi, so that's 1 pi, 2 pi. It just has a translation. It's been slid to the left. Or if you wanted to start your cosine here, you could start here, but then you would be going way over here, and you can't see where that goes. So we back it up to find a spot that we know of. Here, we don't have a dashed line, but that distance to the top and the bottom, the maximum and the minimum, would be the same for where y equals 1. So the midline is still y equals 1. The amplitude is 1. And the period, if we would look at this portion of the graph, we would see from the 0 out to the pi over 2 would tell us that the period is pi over 2. You could even look at a sine graph that starts on the midline and finishes on a midline. And that would be going a quarter and a half. So 2/4, which is a half. All right, we could talk about writing the equations for these. All right, if we look at the equation, if we call this the cosine graph, then we would call this y equals, cosine usually starts up and comes down. Well, this is starting down and going up, so it has to be negative cosine. It's been translated up. It has not been translated right or left at all. So this just looks like, it would have a b though. The b is going to change. So let's do our calculation for b. We know that the period equals 2 pi over b. So in this case, if we called our period pi over 2, and we make a proportion, we put the pi over 2 in place of the period, and we can cross multiply. So now we have pi times b equals 2 times 2 pi. And then we divide by the pi to get the b by itself. Now we have just the 4. So this would be 4x. And the k value is your midline, so that's plus 1. That would be a possible equation for your graph. If we had this equation and we were to translate it, we would say that it's cosine of pi over 4. Now if you're going to translate it 4 units left, that goes in parentheses, goes after the b is on the outside. X to the left means it's going to actually be a positive. So left 2 is going to be plus 2, it's going to go up 3, so it's going to be plus 3. For this one, it's going to be y equals 5, sine of 2x, translated down and translated to the right. If it's going to the right, we use our parentheses, we put our b value on the outside, we put the x on the inside. Translated to the right, pi over 2. So the right's going to be minus. It's always the opposite of what you think. And it's pi over 2. And it's been translated 4 units down. Now for all these graphs. All right. So this one here, this has an a value and a b value. Where I'm going to graph, I'm going to start out with y equals cosine of pi x. And when I do that, I first need to know what my increments are going to be. So let's calculate that. The period for this is going to be 2 pi divided by b. Well, my b value is pi. It's the value in front of the x. So I'm going to say 2 pi divided by pi. They cross off and I get 2. So now I need that to calculate my increment, which is the period divided by 4. So that's 2 divided by 4, which can be reduced to 1/2. So I'm going to count by 1/2. So that's 0. We've got 1/2. Then you've got 2 halves, which is 1. Then you have 3 halves. Then you have 4 halves, which is 2. The cosine graph is always 1, 0, -1, 0, 1. And we can graph that if you like. So we're going to label, since our increments go by halves, and we're starting at, I'll put my 1 and my -1 there. So cosine graph starts at 1 and then 0, then -1, then 0, then 1. So this is y equals cosine of pi x. So next what we're going to do is look at y equals -3 cosine of pi x. And the only difference there is we're going to multiply all the y values by a -3. So that becomes -3 and 0, 3, 0, -3. So instead of starting at +1, we're actually going to start at -3. And then 0, then we go up to +3, back to 0, and then -3. Remember to make your graph so it doesn't look like shark teeth. Try to curve it. So that's going to be y equals -3 cosine of pi x. Our amplitude is the absolute value of A. The period we calculated as 2. The midline is y equals k, and our k value is 0, so y equals 0. Our max number is the highest number, so that's 3. Min number is the lowest number, that's -3. The domain for these trig functions is always all real numbers, and our range goes from -3 to +3. Here we have an a value of pi, we have a b value of 4, so if it has a b value, we need to calculate the period, and that's 2 pi divided by b, so that's going to be pi over 2, and then we're going to calculate the increment, and that's going to be the period divided by 4. And to do that, we take the period and we multiply by the reciprocal of the denominator. So that's going to be 1 over 4. So we're going to count by pi over 8. So we'll start at 0, and that gives us 1 over 8, 1 pi over 8. 2 pi over 8 is going to be reduced. 3 pi over 8. And 4 pi over 8, that's going to be reduced. And that last one is going to be the period. It's always going to match. So you could do this as y equals sine of 4x, and we know sine goes from 0, 1, 0, -1, 0. You could come over here and graph that. We're going to have pi over 8, pi over 4, 3 pi over 8, and pi over 2. So we'll call this 1 and this -1. So sine looks like that. That's y equals sine of 4x. The only place the 4 comes into play is in the scale. It's the only place you see it. Now we're going to do y equals pi sine of 4x. Well, that's an a value. So we take our a value and we multiply all the y values. So 0 times pi, 1 times pi, 0 times pi, negative 1 times pi is negative pi, and 0 times pi. So those are our new points. Well, how are we going to graph pi? Well, pi is the number 3.14. So 1, 2, 3, and a little bit would be pi. Negative 1, negative 2, negative 3, and a little bit would be negative pi. So we're going to climb to here, just above 3, just below 3, and back. So that's y equals pi sine of 4x. This has an amplitude of pi, a period of pi over 2, because that's what we calculated, a midline, that's the k value. We have no k value, so that's y equals 0. We have a maximum of pi, a minimum of negative pi. The domain is always all real numbers, and the range is going from negative pi to positive pi. This next one here, it has a translation and it has a b value. The b value is a half, so we use that to calculate the period. 2 pi divided by b, so we're going to divide it by a half. Well, how do you divide something by a half? You multiply it by the reciprocal, so we're getting 4 pi as our period. So next we're going to calculate the increment, and it's 4 pi divided by 4. So that gives us pi. So that means we're going to say 0, 1 pi, 2 pi, 3 pi, and 4 pi. So because this has a translation with it, what we were doing in class was combining the a and the b into one. So you're welcome to do that, or you can just keep them separated and just do cosine of half x, and then do 3 cosine of half x, and then do the translation. Your choice. So we know that the cosine of half x is going to be 1, 0, negative 1, 0, and 1. And then we times that by 3. So 3, 0, negative 3, 0, and 3. So we're going to come over here. We'll write our scale. We know that cosine starts up high, starts at 1, but we're going to multiply it by 3. So we'll be up here. We're just using the table. At 0, we're at 3. At pi, we're at 0. At 2 pi, we'll be at negative 3. And 0. And 3. So this would be pi, 2 pi, 3 pi, and 4 pi, because the period is 4 pi. Now we take that and we translate it to the right, 3 pi. So that means each one of these dots is going to go 1, 2, 3, 4, 5, 6 lines to the right, or 3 steps, 3 pi's to the right. There's our new points. We curve it right through. This equation was 3 cosine of half x minus 3 pi. The first one was y equals 3 cosine of half x. We know the amplitude is the absolute value of a, so it's 3. The period we calculated is 4 pi. The midline is still 0. We don't have a k value. The maximum number is 3. The minimum number is -3. The domain is all real numbers. And our range goes between those maxes and mins. So -3 to 3. So here we have a b value, so we need to calculate the period. The period is going to be 2 pi divided by b, so the b crosses off and we get 2. The increment is going to be period divided by 4, which is a half. So we're going to start at 0 and do 1/2, then 2 halves, then 3 halves, and 4 halves. This will always be the period. We can do, this first one here is going to be sine of pi x. Really just sine of x, but pi x, that's fine. The pi part is part of this. And we're going to be at 0, then 1, then 0 and -1, and 0. Then we're going to do y equals -1/2 sine of pi x. That means we multiply all those values by a -1/2. We can come over and graph those. So we have 1/2, 1, 3 halves, 2. We call that 1, this -1. So the sine would typically start at 0 and then go up to 1, but now we're going to do half of that and it's a reflection. So we're going to go down to -1/2, back to 0, and then a +1/2 and back to 0. So that's the graph y equals -1/2 sine of pi x and then we're going to do our translation to that, which means we're going to move it 3/2, which is 1/2, 3/2 to the left. So this is a half. This is 1 to the left. This is 3 halves, or 1/2 to the left. So these all move over 3 or 6 lines. 3 halves or 6 lines. So we have y equals -1/2 sine of pi x plus 3 halves. The amplitude is going to be the absolute value of the a, so it's a half. The period we calculated is 2. Oh, I have one more thing to do. I got a k value. I should have moved it all at the same time, but now I need to move these all up 1. So there's my final equation, which is y equals negative 1/2 sine of pi x plus 3/2 plus 1. So my midline is actually up here at my k value, which is y equals 1. My maximum value is 3/2. My minimum value is 1/2. My domain is always all real numbers for these trig functions. And the range goes from 1/2 all the way up to 3/2. This one's pretty simple looking, but it does have a b value. The b value is 1/3. So to calculate the period, we're going to do 2 pi divided by b. So to do that, we multiply by the reciprocal. That's 6 pi. The increment is going to be period divided by 4. So that would reduce to 3 pi over 2. So that's our increment. Those are our steps. So we're going to start at 0, then we'll be at 3 pi over 2, and then another 3 pi over 2 is 6 pi over 2, which can be reduced. 6 pi over 2 plus 3 pi over 2 is 9 pi over 2, and then another 3 pi over 2 gives me 12 over 2, which is 6 pi. So we just have the one graph to do. So sine goes from 0, 1, 0, negative 1, back to 0. We have 0 pi over 2, then we have 6 pi over 2, then we have 9 pi over 2, then we have 12 pi over 2. We're going to start at 0, then go to 1, 0, negative 1, and 0. Let's call this 1 this time and call this negative 1. So that's the equation y equals sine of 1/3 x. The amplitude is 1. The period we calculated is 6 pi. The midline is y equals 0. The max is 1. The min is negative 1. Always all real numbers. From the minimum to the maximum. Okay, you're always welcome to pause the video, try these on your own. You should never copy me for the review. Alright, we see a b value of 2. So we have to calculate a period. That's 2 pi divided by 2, so our period is pi. And our increments are going to be pi divided by 4. So we're going to get 1 pi over 4 and 2 pi over 4, which can be reduced, and 3 pi over 4, and 4 pi over 4. We know that this would be the cosine of 2x. Okay, this is cosine, so it starts at 1. And then we're going to do y equals a half cosine of 2x. That means we take halves of all of those. So we can come over. We have pi over 4, pi over 2, 3 pi over 4, and pi. We got that from our table. So typically cosine would start up at 1, but we're going to do half of that. That's where we get this half from. Half, 0, negative a half, 0, and a half. So a half, 0, negative a half, 0, and a half. So this is going to be y equals half cosine of 2x. And then we're going to translate this graph up 1. Each line is a half, so we have to go up 2 halves. Our amplitude is the absolute value of A, the period we calculated. The midline is our K value, so y equals 1. Our highest point is 3 halves, our lowest point is a half. So our range is a half, 3 halves. And our domain is always all real numbers for these trig functions. Just a couple more. So we have no b value, so there's no need to recalculate an increment. So we're at 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to work with, this first one would be sine of x, which is 0, 1, 0, negative 1, and 0. And then we'll do the equation 2 times the sine of x, which is multiplying those by 2, by the a value. So now we can come over, we can put our pi over 2, pi, 3 pi over 2, and 2 pi. Label out our scales. We know that we're going to be starting at 0, 0 because this is a sine graph. And then we're going to go up to 2, back to 0, then negative 2, back to 0. And then we're going to take that graph and move it pi to the right and 3 units down. So pi is going to be 2 units to the right. So that's 1 pi. That's what we're supposed to do. And then we're supposed to go 3 down. So this is y equals 2 sine of x minus means it moves to the right, and then minus means that it goes down. Our domain is the absolute value of a. The period is 2 pi. The midline is our k value. We should do our dotted line to represent the midline. So that's y equals negative 3. We knew that because the k value was negative 3. Our maximum value was negative 1. Our minimum value was negative 5. So our range goes from negative 5 to negative 1. Our domain is all real numbers. There was no reflection. There was a vertical stretch by a factor of 2. And then our translation was pi right and 3 units down. So here we have a b value. So we have to calculate the period. That's 2 pi divided by b. Well, we don't divide by a fraction. We multiply by the reciprocal. Those cross off and we get 8. And then to calculate our increment, that's the period divided by 4. So we're going to count by 2's. So that's 0, 2, 4, 6, 8. And if we're going to do sine of pi over 4x, that's going to be 0, 1, 0, negative 1, and 0. That's the basic format. And then we're going to say y equals negative sine of pi over 4x. So we multiply all these by a negative 1. So now we're going to come over and do our 2, 4, 6, 8. We appreciate. And our scale, it looks like we got to be able to translate a pretty far distance, so we're going to have to count just by ones. So sine is 0, 0, and as a reflection, so it comes down. So this is y equals negative sine of pi over 4x. And then we're going to translate that 4 units down. Notice the 4 is not in parentheses. That means it's not right and left. It's up and down. The amplitude is the absolute value of the A. The period we calculated as 8. The midline is our K value of 4. That means in my graph I need to label my midline as y equals negative 4. The K value. The highest number is negative 3. The lowest number is negative 5. So we're going from negative 5 to 3. And the domain is always all real numbers. Last one. So we don't have a b value. B value is just 1. So we know that we're going to do pi over 2, pi, 3 pi over 2, and 2 pi. That makes that nice. So we'll be able to do the cosine of x, which is 1, 0, negative 1, 0, and 1. And then we'll do our translation of negative 4 cosine of x. So we multiply all of these by a negative 4. So we come over, call this pi over 2, pi, 3 pi over 2, and 2 pi. We'll count by ones. And our graph is going to, this is cosine, so typically we start at 1, but we're going to multiply by negative 4. I'm just using my table here. So I'm going to start at negative 4, and then I go to 0, and then I go to 4, and back to 0, and back to negative 4. So that's y equals negative 4 cosine of x. And then we do our translation of pi over 2 to the left and 1 up. So pi over 2 to the left, because it's plus pi over 2, that means the left. So we go over there, but 1 up. Over and 1 up. Over and 1 up. So that's y equals negative 4, the cosine's upside down, and stretched, and translated left, and up. My domain is all real numbers. My range goes from negative 3 to 5. I have a reflection over the x-axis, have a stretch vertically by a factor of 4, and I'm translated pi over 2 left and 1 unit up. My amplitude is the absolute value of A. My period was 2 pi. My midline was 1. That means I should put my dashed line through the middle there at y equals 1. My maximum value is 5, and my minimum value is -3. Good luck.